Good evening to lecturers and fellow friends. So today we are represent Group 10 to present about numerical linear algebra for chapter 5, which is the system of equations. So next slide. So in this task, we have provided 3 questions. So each of us are handled for 1 questions. So our teammates has as me, as Eng, and Chan, and Hao Yimei. So for the question 1 will be handled by Chan. So Chan.
Okay, thank you, Eng. So I'm Chan. I will be handling for question 1. So for question 1, a country has 3 regions. Each year, 10% of the residents of region 1 move to region 2 and 5% move to region 3. Then 15% of the residents of region 2 move to region 1 and 5% of region 2 residents move to region 3. And also 10% of the residents of region 3 move to region 1 and 10% move to region 2. As each region has a population of 100,000 initial state of populations. So the question asks us to find the population of each region in 1 year and in 3 years. Right, next slide. So first, we can find 3 equations for each 3 regions. As you recall the questions, there are 10% of the resident region 1 move to region 2 and 5% of resident of region 1 move to region 3. So 100% is minus by 10 and 5 is left by 85%. So as the first region, we have 85% of region 1 resident remains after years. So we can form an equations as 0.85 plus 0.15x2 and 0.1x3. The x represent the initial state of each regions. So we can form the matrix as shown there. So as given, the initial state population of each region is 100,000. Therefore, we can calculate the matrix. Then we got 110,000 in region 1 and 100,000 regions in region 2 and 90,000 in region 3. So next slide. So for B, we just need to change the initial state of population of regions from the previous years for each region in 3 years. So for the first year, the initial population is given that 100,000 for all. X1, X2, X3 is 100,000. So we can find out that the initial population for second years is for region 1 is 110,000. For region 2 is remain the same, is 100,000, and for region 3 is 90,000. So we can do by doing the same step as shown just now, and we can predict the population for the second years. Then we can find that there are 500 in region 1 and 100,000 in region 2 and 82,500 in region 3. Then we use that for the initial state population for the third year. So we can conclude that there are 123,125 population in region 1 in the third year and 100,000 in region 2 and 76,875 population in region 3. Right, that's all from me. We move on to the next.
So thank you, Chan, for explaining question 1 with a very good comments. So we will move on to the questions 2. So questions 2 is like this. 300 people are going a Caribbean cruise. So when the ship stops at the port, each person has a choice of going on the shore or not. So 70% of the people who go on the shore on today will not go on the shore on the next day. And 60% of the people who do not go on shore on the day will go on the show for the next day. So today, 200 people are going on show. So question asks us, how many people will go on show tomorrow and the day after the tomorrow? So next slide. So from the information given by the questions, we can denote the X1 as the people will go on the show tomorrow, and X2 denoted as the people will go on the show the day after tomorrow. So we can conclude the information as 70% of the people who go on the show on the day will not go on the show on the next day. Means well, there are 30% of the people who go on the show on the day will go on the show on the next day. Then 60% of the people who do not go on the show on the day, they will go on the show for the next day. Means well, got 40% of the people who do not go on the show on the day will not go on the show for the next day. So based on this information given, so we can conclude full system of equation as 0.3x1 plus 0.6x2 equal to 200, which the people will go on the show on today. So second is the 0.7x1 plus 0.4x2 equal to 100. That's a balance of the people who do not go. So then this set of equation can be rewritten in the matrix form as 0.3, 0.6, 0.7, 0.4 multiplied by x1, x2, and equal to 200 hundredths. So let A be the matrix 0.3, 0.6, 0.7, and 0.4. And let the X matrix be the 200 and hundredths. So next slide. So noted that for this matrix operation, we just need to take the first column value as the people who will go on the show depends on the day requirement. So for calculate the people who go in the show on tomorrow, which is x1, we can use the matrix operation, which is let matrix A multiplied by matrix X. So matrix AX will be multiplied by matrix A and matrix X. So hence we can get the 120 people will go on the show on tomorrow. So next, we can move on to the X2. So when calculating the X2, which denoted as the amount of people will go in the show on the day after tomorrow, so we are using the matrix operation, A multiplied by A and multiplied by X. So we can rewrite them in matrix A square X. So using these matrix operations, we will get 144 people will go to the show on the day after tomorrow. So that's all for the questions 2. So we will move on to the question 3, which handled by email.
Okay. Thank you, Ng and Chan, for the explanation for question 1 and 2. And now we will move on to question 3, which is the question is, as a promotional feature, a store conducts a weekly raffle during any week. 40% of the customers who turn in one or more tickets do not bother to turn in tickets the following week. And on the other hand, 30% of the customers who do not turn in tickets will turn in one or more tickets the following week. So the question wants us to find and interpret the steady metrics for this situation. So there are two situations in this question, which are customers who turn in one or more tickets but do not bother to turn in the following week, and customers who do not bother to turn in one or more tickets but turn in the following week. So during any week, there are 40% of the customers turn in but do not turn in the following week, and the rest turn in the following week, which is 60%. And on the other hand, 30% of the customers do not bother to turn in but turn in the following week, and the rest do not turn in the following week, which is 70%. So now we create a transition matrix. We name it matrix P with this column as any week and its row as the following week, which is 0.6, 0.3, 0.4, 0.7. And to find the steady matrix by using the information given, we can write in matrix form as 0.6, 0.3, 0.4, 0.7 multiplied with x and y and equals to x and y. So from here, we can conclude 3 sets of linear equations. The first equation is 0.6x plus 0.3y equals to x, And then the second equation will be 0.4x plus 0.7y equals to y. And then the third equation will be x plus y equals to 1. The third equation is the outcome of the customers that turn in and do not bother to turn in the one or more tickets. And then x denoted as the customers that turn in one or more tickets, while y denoted as the customers that do not bother to turn in one or more tickets. So now we have simultaneous equations, and we use third equations and write it as x in terms of y, and then we will write in x equals to 1 minus y. Then we substitute the equation into the first equation, which is we will get the value of y equals to 4/7, and then we will substitute the value of y into second equations, and then we will get the value of x, which is 3/7. And in conclusion, 3/7 of customers that turn in one or more tickets, while 4/7 of customers that do not bother to turn in one or more tickets. So now we prove this is a steady matrix by substitute the value of x and y into the matrix. So we will get the same matrix again. So this is the steady matrix. So thank you for listening. Okay. So this is the reference. So that's all for us. Thank you.